Amen. All right. Lucy, would you mind just closing the doors? Because I'm sure the youth are going to be flying by at some point and might be a bit of an issue. Okay. Well, welcome to Is Atheism Dead? This is based on the book by Eric Metaxas. Anybody ever heard of Eric Metaxas before? Okay. He's a prolific author. He's a U.S. guy, very dynamic speaker. He's really well read, well informed, well connected. Has his own podcast, own TV show, and all that stuff. Anyways, I actually read this book. It was more than a year ago, and I remember reading it as a pastor and just being like, I really want to share all this stuff with the church. But just trying to find the window of when you could drop this type of material in, it's very difficult, but still felt the need. And then, of course, when our course finished 2 weeks ago, we kind of kicked around the idea of this. And so I revisited it, and then I thought, let's do it, because we can just do it simply. And it can be 3 weeks, and we can just do a quick hit. If you want to get the book or read the book, I would very, very highly recommend that. I have basically just put everything in the notes, so if I'm really confusing as I'm sharing, or if I say something that's just wrong or weird, you can always refer back to the notes and fact check me. And the reason I'm saying that is because I have 3 caveats, and the number 1 caveat is I am not a scientist nor an expert in this at all. I am the blind leading the blind here, okay? So I'm fully admitting that. That's full disclosure. This is just something for me where my heart as a pastor was just on fire as I was taking in this information. I found it enlightening, encouraging, edifying, all of those E words that we use in the church, and just kind of blew my mind. So I'm just going to bring you this information. You can disagree with it. I'm totally fine with that. You can, whatever. You can do whatever you want with the information. I am just going to be a messenger and just go, here's the information as best that I can deduce and give to you. The second thing is, and one of the reasons for me to do this, one of the reasons I'm excited to do it and passionate about doing it, is just the basic idea of the proliferation of science in our culture. And so whether it's technology, like we have all of this technology that's running everything all based on science, whether it's medication and we have an ailment or we have an issue and we need surgery, where do we go? We go to the doctor. It's the whole idea of evolution is all throughout movies. It's in our education. It's all of those things. Science, it basically has become a religion. It's become a mindset for our culture. And I believe what we're going to do tonight is we're going to do the job of not leaving that unchecked. Okay? So I'm okay with science being awesome and helping us and all those things. However, there is kind of this, again, you want to talk about blind leading the blind. Sometimes we just blindly believe and blindly follow. You'll understand some context of this in a second. But, we just have this blind belief and a buy-in that I feel like as Christians and as believers, we should just check that. It's the idea that science couldn't be wrong, could they? Could science? Could they be wrong? I don't think so. We're gonna put them to the test, and that's what tonight's all about. That's what Eric Metaxas did, and that's what we're gonna do. And then the third thing here, and I'm glad that Lucy and Michaela, I'm glad you guys are here, because you guys are in the thick of it. You probably have gone through some science classes and all of those things. And so again, to my point, number 2 is it's basically just open wide, and here we'll give you the doctrine that you're supposed to know, which is we came from apes and we all evolved and all of those kinds of things. And so this is a counter argument. I would call it the truth based on the Bible. And so this is just a complete different way to look at things. And so I appreciate that you guys are here. Number 3 was, as I was reading this, I was coming to the realization that I had not heard any of this before. This was all new. This was basically brand new information. And I think that is his point about this. And so he even says in the book, and I watched a couple of his sermons, and he's just like, why aren't pastors saying all this from the pulpit? Like, why do they not, how come we haven't heard this before? And so it really gave me, again, some drive to want to get this out. He has a quote here. I'm not sure if the quote is there. The quote goes something like this, and this is right in the beginning of his book, and he says, "We are generally stuck in the secular narrative that reached its apogee," which means high watermark, in the 1966 Time magazine cover article with the infamous title, "Is God Dead?" And ... there's a couple more sentences, and then he says, "Most of us have carried on with that idea ever since." And so if you are of a certain ilk, you'll probably remember this in, doctor's offices, or, maybe you subscribe to Time. I don't know, maybe it was at your house. Do you remember this coming out? Anybody? This predates me, but, okay. This is one of their most famous magazines, and it came out in 1966. We're going to dial back to the reason that it came out in 1966, because science hit this watershed moment where they really got ahead of themselves. Eric Metaxas' theory would be that ever since this happened, the church went silent on science and basically are cowering in the corner because science somehow is absolutely true, unquestionable, and the church, we just have to kind of lump along and just believe in Jesus and just try our best to do, to live by what Jesus talked about. So what happened was Eric Metaxas started to do some research. He wrote a book, and here's another one of his books. I'll give you a little introduction here. Eric Metaxas, that's the radio show, that's him. And then here is another book that he wrote. This book's called Miracles, and so in the book of Miracles, he talks about the fine-tuned argument of the universe, and we're going to get to that. You'll see it in your notes. There's a lot there. His publisher says, well, if you're going to publish this book, what we should do is we should get you to do an op-ed or an opinion article and put it somewhere so that people can latch onto it, and it will start to raise awareness for the book and publicize the book, right? Which is a smart thing for a publisher to do. And so he initially titled the article about this whole fine-tuned argument about the universe, he entitled it, "Is Science Leading Us to God?" Right? He's a devout Christian, evangelical Christian. Is science leading us to God? They changed the title, Wall Street Journal, this is where it came into. Science increasingly makes the case for God. So of course, everybody's going to be super interested about that. So this is back in 2014. It came out on Christmas Day or the day after. I think there's a couple of different versions there. Eric Metaxas was on vacation, but he started to watch the likes and shares come through on Facebook and through their social media platform with the Wall Street Journal. People were really interested in this article, started to read it. So much so that it was shared 100,000 times in that first week. And it wasn't long before then it was shared 200,000 times, and then it kept going. He talked to the people at the Wall Street Journal, and they said, well, the record for Wall Street Journal back 2014 was 300,000. So they stopped counting at 600,000 likes and shares and all the stuff. It went viral. Okay, so that was and his deduction with this was people were hungry for answers to the big questions. And much like the feeling I had in my car as I'm listening to this audiobook and I'm driving along just going like, yeah, why don't we know this stuff? It just kind of drove me to be excited about that. It's obviously what was going on for him as well. So we're going to break this down in 3 weeks, and he breaks his book down into 3 parts, 3 sections. Tonight we're going to cover the 2 things you see there at the top. Number 1 is the discovery of the Big Bang. Don't be offended by that. I'm just going to use the term loosely. I've come to grips with the fact that both scientists, even Christian scientists, will use the terminology of the Big Bang. They usually mean when God said, let there be light. You know, that's the bang. But they still call it the Big Bang. And so just don't be put off by that. It was the beginning of the universe, essentially. So we're going to cover that tonight. We're going to cover the fine-tuning of the universe in 3 different ways tonight as well. Next time, we're going to talk about how life emerged from non-life on Earth. If you've ever looked up a guy named Frank Tour, go ahead and fill your boots with this guy. He is a fantastic scientist, devout Christian, evangelical, but we're going to talk about that in the next section, and then in the next session, and then in the third and final session, we're going to talk about archaeology. So all of this science fine-tuning we're going to talk about tonight really makes a great case for God. Next time, we're going to talk about the nano end of things, the small particles and all of those things. That really makes a case for God. And then also, all of the archaeological digs and finds that they've had in the last number of years is also going to make a great case for God. So I hope you enjoy. I honestly, I know how to preach. I know basically how to do that. Start with a story, go through your points, go through the Bible. But this is essentially more teaching. And so bear with me. Appreciate your grace, but we're going to essentially just walk our way through the content that I basically just took all day just to kind of put together, and I hope it's edifying to you. So if not, get the book and read that, and we'll do a better job. Okay, so here we go. So number 1. So the beginning and the expanding of the universe. I have a groovy little slide here. Is this it? Okay, there we go. Just so we know where we are. Okay, so the story of the Big Bang. So again, he does a great job kind of really working through where this concept came from. And so it's a deep dive into the history of scientists around the turn of the century. So he throws around names like Einstein and Hoyle. He talks about a guy named Andy Sandage, and I have a picture of him here, because this man actually came to faith in Christ in the process of watching the stars and watching the cosmos. And so here's basically the idea. There was a time, and let me just start with this. There was a time when science believed that the universe had no beginning and that the universe was static. Okay? And then this man, Andy Sandage's mentor, was a guy named Hubble, Edwin Hubble. You might have heard of him from the Hubble telescope. So Hubble spent all this time staring at the stars, and he actually believed by observation that the universe was expanding, that the universe was moving, it was growing, it was alive, essentially. This kind of fit around that time in the early 1900s with a man you may have heard of named Albert Einstein, who in 1905 wrote a little thing called the theory of relativity, which turned the entire scientific world on its ear. And in 1915, Albert Einstein wrote another paper on the idea of light and all the photons in light and the power of gravity and the fact that gravity could bend light and all of these kinds of things. It was a dynamic article. And in that article and in his research, he also deduced that the universe was expanding. So I'm coming to a point, so you got to just track with me here. But he denied that it was happening. He actually brought this thing called the cosmological constant. And so whenever he was doing mathematical equations, he would always add this cosmological constant, even though he deduced that the universe was expanding. There was a man in Russia, his name was Alexander Friedman, and he used to read Albert Einstein's work, and he believed Albert Einstein's theories of relativity and all of those kinds of things, but he believed that it required the removal of this cosmological constant. He was picking up on the idea that also the universe was expanding, and he was just like, I wonder why Albert Einstein didn't figure this out. He's a smart guy. He's smarter than me. I'm reading his stuff. Why isn't he figuring it out? And so he said that the theory of relativity and all of those kind of things required a moving universe. And then there was a man, and actually I didn't do a deep dive on him, but I'd love to do it. There was a guy named George Lemaitre. Le Maître. Who's French in this room? Le Maître. I don't know if I'm getting the accent right, but anyways, his name is George Lemaitre. He also deduced that the entire universe had expanded from an initial point, which he called the primordial atom. Okay, so for millennia, they believed that the universe was timeless, always been around, and also it was static, not moving. And then these guys, the top minds of science, all of a sudden started to piece things together and go, hang on a second. This isn't what I originally thought it was. And so it was really this George Lemaitre, because all of those other things were just kind of in the wind, but then he actually went ahead and proposed the idea of the primordial atom in the 1920s, meaning that there was a beginning to the universe. Okay? So it's kind of scary. It's like, well, what? Well, how do we know about this? How can we measure this? But he deduces this. And then he reasoned that if the universe is expanding, it must have been smaller in the past. And he used quantum theory to argue that the universe began as a single particle. And his belief was that the particle exploded, giving rise to space and time and the expansion of the universe. You still with me? Okay? Again, none of us in this room spend any time working on any of these equations, but you can imagine the amount of work it would take and also the amount of faith it would take for them to do something that was against what has been believed for millennia. The universe has always been, and the universe is static. All of a sudden they're like, no. The universe had a beginning, and the universe is actually expanding as we speak in this moment. So when this came out, there was number one, it was Einstein that really poo-pooed the idea, because he said this actually reeks of the creation story in the Bible. He was like, I can't go with it. So it was really more of a thing, inside of him personally, which is amazing, because the Bible was written, and in the beginning part was written 3,000 years before Newton actually discovered gravity. So the Bible was ahead of Newton by 3,000 years. Yet even Einstein, hundreds of years later, couldn't actually, kind of fess up and go, yeah, the Bible actually is onto something here. So in the past, here's a fun fact, Einstein finally admitted what he already knew. Because remember the cosmological constant? Moving that aside, I don't believe in this whole thing. He considered it his greatest blunder. You can look this up for yourself. Look up Einstein's greatest blunder, and he will say, was to be the introduction of the cosmological constant in his equations of general relativity. In 1917, Einstein modified his field equations of general relativity by adding a cosmological constant to counteract the gravity and maintain a static universe, which was then the accepted view of the time. When Einstein realized this, he reportedly called the addition of this cosmological constant his greatest blunder. Because he was just trying to hold up the scientific community and just go, well, this is what we've always believed. They're going to think I'm a nitwit. They're going to think I'm nuts if I say, I think the universe is expanding based on my calculations. So, so then there was a man named Fred Hoyle, which if you ever think of the term according to Hoyle, that's this guy. And he's a famous scientist as well, but the idea of the steady state theory was something that he wanted to hold on to, and so in 1949 in a BBC interview, he sneeringly described this ridiculous idea as the Big Bang. And from that day till this became known as the Big Bang theory, and everybody has used it since then. And these theories completely shifted once and for all. So as of today, we do not believe in this steady state universe and the fact that the universe has always been. We believe that the universe was something like 13.8 billion years ago, right? Hang on a second. Yeah, 13.8 billion years ago, and they figured this all out. Stephen Hawking did math. They figured out when the universe actually began. And they also believe that the universe continues to expand at this time. And so, this is tough, right? Because evolutionists, when they came along, they needed there to be limitless amounts of time for all of the chance random planets and random life amoebas to come together, the primordial ooze. They just needed time for all of that experimentation to happen so that life could start to evolve and become what we are today. But that was now off the table because now there was a beginning point and evolution was essentially on the clock. And also, we have a universe that was expanding from one event, from one moment, which coincides with the creation story from the Bible. In the beginning, God said, "Let there be light." Bang, and there was light. Amazing. And so then we have also this, we've established the fact that there was a time when the universe wasn't, and then there was a time when the universe was. And so all of a sudden they're like, how do we figure this one out? We don't have any explanations. You with me? Okay. So here's the fun fact, and I think this is from Metaxas himself. I was listening to it and just writing some quotes and stuff, but here, listen to this quote. You probably love this. I don't know if you have this in your notes. Physics, which Albert Einstein was all about and all these scientists, physics eventually proved that the laws of physics had not always existed, nor had the universe in which they manifested themselves. Put your mind around that a little bit. So, I don't know if I can state it emphatically enough, but this was groundbreaking, ground-shaking in the scientific community. The problem with that is the Scopes trial. When was the Scopes trial? 56? I think it was like 56, right? Darwin and all that stuff. We came from apes. That happened after. And so in 1949, the Big Bang happens. 1956, Scopes trial. And then in 1966, you have Is God Dead? And so with those three markers, for most of us, your parents, my parents, would have believed that science has trumped the truth of the Bible. You with me? So for generations now, we're kind of on this like, we're being bullied by science, essentially. So we're going to move on to the fine-tuning of our planet, of Earth, and also of the universe. And as we do this, I want to do three things. Number one, I want to apologize. Because I think I said with our Islam group, and I was absolutely adamant about that when Christopher Hitchens was asked, what is the actual proof that God exists, he said the Jews. Anybody remember that? You were listening? Okay. He may have said that. However, I have video footage that he said something different at another time. Okay, so I want to apologize there. So what I'm going to show you is a behind the scenes, it's not an interview, but it's actually a moment when Christopher Hitchens is caught on camera by saying if he was going to debate for the existence of God, he would use what we're about to talk about. So if you don't know who Christopher Hitchens is, he's probably the most vitriolic, but also prolific debater against the fact that there is a God. Christianity, Islam, Judaism, he just thinks they're all fairy tales and we all should grow up and move on with our lives. No such thing as God. So he's the atheist's best spokesperson. And so you're going to see him here in a video clip, and he's going to talk about the fine-tuning of the universe. I hope this works. I hope we get the audio.
At some point, certainly, we were all asked, well, which is the best argument you've yet come up against from the other side? And I think every one of us picks the fine-tuning as the most intriguing.
The Goldilocks.
Yeah. The fine-tuning that 1 degree, one hair different, nothing. But even though it doesn't prove a designer could all have happened without it, you have to spend time thinking about it, working on it. It's not a trivial. We all say that. And then at one point, I think this is not on camera, I said, if I could convert everyone in this world, not convert, if I could convince to be non-believable, and I've really done brilliantly, and there was only one left, one more, and then it'd be done, and there'll be no more religion in the world. No more tears. I wouldn't do it. And Jordan said, what do you mean you wouldn't do it? I said, I don't quite know why I wouldn't do it. And it's not just that there would be nothing left to argue with and no one left to argue with. It's not just that. Though there would be that. Somehow, if I could drive it out of the world, I wouldn't. And the incredulity with which he looked at me stays with me still.
That's a powerful moment. That's a powerful moment. What did you get out of that?
Nothing.
Nothing? No? Okay.
They need the brakes fixed.
And the shocks, apparently, right? Okay. Who got anything out of that? What were you surmising from that? Nothing? Okay.
He still has 1% thinking there is God. It seemed like he wasn't 100% there. Maybe 99%.
Yeah. Has anybody? Have you ever seen this guy in action? Anybody? He is. Do you know what vitriol is? Like hatred. Like when he speaks to people. Like most times when you're debating, you use like grace and you try to be kind and those kinds of. He doesn't. He just like he's like Simon Cowell on steroids, but when it really matters, right? Okay. So, anyways, he's passed away, so he's probably not going to sue me for saying that. I'm not going to say anything. Okay, Misty.
I got out of it that he wouldn't want the world to not have a religion. That's what I got. Though I think he thinks the world is obviously a better place with religion.
Yeah. Right. Okay. Yeah. That was the back half, and what a powerful thing to say, because what he kept on saying, we all say it. We would all use it. That would all be our argument. So he's talking about Richard Dawkins, who is another famous atheist, and the other guy's name escapes me, but there's three of them that are they're the top of the top of the top, or were the top, and they would all use this argument. That's what he's saying, right? And so the idea of the fine-tuning argument, he was saying that I would really have to think about that, I'd really have to study it, I'd really have to come up with a great answer for it. Idea being that it's almost airtight. What we're about to cover is what he said that he would use. Okay, you with me? Okay? No? Okay. So what'll happen is, and maybe the problem for me is that I know what fine-tuning is before I see the video, so when I hear him say it, I know I have a little bit of context. So what I think we'll do is move forward, because I have another video that's going to explain what fine-tuning is. Okay, fine-tuning. And did you hear him mention Goldilocks? Right? So okay. In the video, he mentions Goldilocks. How many people have heard of the nursery rhyme Goldilocks and the Three Bears? Okay, good. Okay, we finally found some common ground. Okay, so what happened with Goldilocks, right? She goes in, right? The porridge, this one's too hot, this one's too cold, and this one's
Just right.
eats it all up, right? And then on and on and on. So that is the idea of the fine-tuning argument, or the fine-tuned argument of our universe, is that our universe is exactly just right for us to exist and have life on this earth. It's not too much of this. If it was, life wouldn't exist. It's not too much of this. If it was, life wouldn't exist. It is just right. And if it's just right, how did it become just right? So we're recognizing there was a beginning, we're recognizing that there's motion, but how in the world did it become just right? Are we just lucky? Is this a matter of chance? Okay, are you, right? You following that? So this video is going to describe it, and just try to catch as much of it as you can. It's really well done video, but it'll talk about what the definition of fine-tuning the universe is, and then we'll walk through this. And probably once we start talking about this, yeah, it'll click in. So just check this out. It's about 5 minutes long, 6:22 to be exact.
From galaxies and stars, down to atoms and subatomic particles, the very structure of our universe is determined by these numbers. These are the fundamental constants and quantities of the universe. Scientists have come to the shocking realization that each of these numbers has been carefully dialed to an astonishingly precise value, a value that falls within an exceedingly narrow, life-permitting range. If any one of these numbers were altered by even a hair's breadth, no physical, interactive life of any kind could exist anywhere. There'd be no stars, no life, no planets, no chemistry. Consider gravity, for example. The force of gravity is determined by the gravitational constant. If this constant varied by just 1 in 10 to the 60th parts, none of us would exist. To understand how exceedingly narrow this life-permitting range is, imagine a dial divided into 10 to the 60th increments. To get a handle on how many tiny points on the dial this is, compare it to the number of cells in your body, or the number of seconds that have ticked by since time began. If the gravitational constant had been out of tune by just one of these infinitesimally small increments, the universe would either have expanded and thinned out so rapidly that no stars could form and life couldn't exist, or it would have collapsed back on itself with the same result: no stars, no planets, and no life. Or consider the expansion rate of the universe. This is driven by the cosmological constant. A change in its value by a mere 1 part in 10 to the 120th parts would cause the universe to expand too rapidly or too slowly. In either case, the universe would again be life prohibiting. Or another example of fine-tuning. If the mass and energy of the early universe were not evenly distributed to an incomprehensible precision of 1 part in 10 to the 10 to the 123rd, the universe would be hostile to life of any kind. The fact is, our universe permits physical, interactive life only because these, and many other numbers, have been independently and exquisitely balanced on a razor's edge. Wherever physicists look, they see examples of fine-tuning. The remarkable fact is that the values of these numbers seem to have been very finely adjusted to make possible the development of life. If anyone claims not to be surprised by the special features that the universe has, he's hiding his head in the sand. These special features are surprising and unlikely. What is the best explanation for this astounding phenomenon? There are 3 live options. The fine-tuning of the universe is due to either physical necessity, chance, or design. Which of these options is the most plausible? According to this alternative, the universe must be life-permitting. The precise values of these constants and quantities could not be otherwise. But is this plausible? Is a life-prohibiting universe impossible? Far from it. It's not only possible, it's far more likely than a life-permitting universe. The constants and quantities are not determined by the laws of nature. There's no reason or evidence to suggest that fine-tuning is necessary. How about chance? Did we just get really, 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 really lucky? No. The probabilities involved are so ridiculously remote as to put the fine-tuning well beyond the reach of chance. So, in an effort to keep this option alive, some have gone beyond empirical science and opted for a more speculative approach, known as the multiverse. They imagine a universe generator that cranks out such a vast number of universes that, odds are, life-permitting universes will eventually pop out. However, there's no scientific evidence for the existence of this multiverse. It cannot be detected, observed, measured, or proved. And the universe generator itself would require an enormous amount of fine-tuning. Furthermore, small patches of order are far more probable than big ones. So the most probable observable universe would be a small one, inhabited by a single, simple observer. But what we actually observe is the very thing that we should least expect: a vast, spectacularly complex, highly ordered universe, inhabited by billions of other observers. So even if the multiverse existed, which is a moot point, it wouldn't do anything to explain the fine-tuning. Given the implausibility of physical necessity or chance. The best explanation for why the universe is fine-tuned for life may very well be it was designed that way. A common sense interpretation of the facts suggests that a superintellect monkeyed with physics, and that there are no blind forces worth speaking about in nature. The numbers one calculates from the facts seem to me so overwhelming as to put this conclusion almost beyond question. There is for me powerful evidence that there is something going on behind it all. It seems as though somebody has fine-tuned nature's numbers to make the universe. The impression of design is overwhelming. The heavens declare the glory of God. The skies proclaim the work of his hands. Day after day they pour forth speech. Night after night they reveal knowledge.
Okay, dare I ask, do we get anything from that? What'd you get? What are you picking up?
God made the universe. Yes.
Okay.
Absolutely.
There's a designer.
Yes.
Yeah. Okay. Anybody else? Care to comment? Overwhelmed?
Mine.
Lost? Yeah, okay. So hopefully what we're going to cover here will actually put some meat on the bones that we're building here. Do you have the Carl Sagan's quote here? You guys have that in your notes?
Just a question, by the way.
Go ahead.
When they said there's like billions and billions and billions of stuff in our body.
Mm-hmm.
Okay. How did they measure that?
Well, they count them.
Yeah.
Yeah.
Yeah, billions of them to count them.
Yeah. I don't know. I'm not, like I said right at the beginning, I'm not a scientist. But you saw those equations. In this book, they talk about the weight of the universe. And they have the ability to actually deduce how much the universe weighs. And I'm like, what? How do you know that? So anyways, way beyond me. I have to trust. So, but anyways, yeah. But I think the human body, that would be reasonably easy compared to the weight of the universe. But let's keep moving forward so we don't totally bottom out here. 1966, famous astronomer Carl Sagan. You heard of that name before? Famous guy, TV guy. He was an astrological astronomer, all those things. He said in 1966 there are only two parameters for life on Earth. He said the right kind of star, check that box, we have that, and a planet the right distance from that star. Okay? So here's the thing though. From that moment, the more science looked into this, the more they discovered this whole thing, which is relatively new, this fine-tuning argument of the universe. So they found, Carl Sagan said there's two, and then they found two more, and then they found a dozen, and then they found 50, and then they found 100, and then they found 200, and all of a sudden they're just like, wait a second, this is really finely tuned, like that radio dial that was just right in, has to be like that for life to exist. The only rational answer for our existence was that the universe had been intentionally designed so that life here could exist. And we were deducing that Earth provides the perfect environment for human life. Okay, so flesh on the bones. Number one is the size of our planet. The size of our planet. So this is all Eric Metaxas' stuff. He says if our planet was larger or smaller, life as we know it could not exist. Why? Because if it was smaller, Earth's magnetic field, again, I know, probably haven't thought about this ever. This is the stuff they think about. Earth's magnetic field, if the planet was smaller, the magnetic field would be weaker, and our magnetosphere, which is perfect for us right now to protect us from the sun and the sun's rays, would be stripped away, and all of the hydrogen and oxygen would be stripped away with it. We would essentially be like Mercury, which is so close to the sun. Also, the size of our planet, if our planet was any larger, we would have more powerful gravity than our atmosphere, in our atmosphere, and our air would be too thick to breathe. Okay, scientists are deducing this. So there would be no water and carbon dioxide, no water, carbon dioxide, or methane could escape our atmosphere, and so we would basically suffocate because everything would be held down by gravity. Okay, go with me on that. Also, and we'll talk about this in a second, this may be kind of a throw-in, but the distance from Earth to the sun is the exact distance it needs to be, or else we would, if it was any closer, we'd melt. If it was any further away, we would freeze. You with me on that? How many people have heard that one before? Okay, so that's kind of the land that we're living in right here. Goldilocks, you know, not too hot, not too cold, just right. Okay, so our position from the sun, yeah, water would have evaporated or frozen. And then we'll probably get back to this as well. In terms of, okay, this is the size of the Earth. This is I'll just give this point. It'll probably come a little bit later on as well. In our solar system, we have all these planets. Do you know the planets? Mercury, Venus, Earth, Mars, Saturn, Jupiter, Uranus, and Neptune, and then Pluto, but we don't talk about Pluto anymore, poor Pluto. Okay, but Jupiter is ginormous in its scope, and so the idea of any asteroids coming towards Earth is actually, Jupiter kind of does the job of a linebacker, is what Metaxas says. Planetary linebackers which vacuum up asteroids and protect us by deflecting or absorbing them. And so again, the position in the solar system is also important. So position from the sun, position in the solar system is also really finely tuned. And then the moon, which again we look at, but we don't normally think about. The moon is outrageously large compared to any other moons in the solar system. So Earth has one very, very large moon, 27% the size of the Earth. Mercury has no moons. Mars has 2 small moons. Venus has no moons. Jupiter has 79 moons. 79, that's a lot. Little tiny guys. Saturn has 82. Uranus has 27. And Neptune has 14. We're the only planet that has 1. A lot of them have none. A lot of them have a lot. We have 1, and it's huge. It's huge. And so we'll talk about that in a second. One of the most interesting things I found out about the book, in the book, was the distance from us to the sun. And there's a mathematical equation about how many moons fit in that. And I won't go into all that. You can do that for yourself. However, the idea of the distance to the sun and the size of the sun, because you know the sun is like 1,000,000 times bigger than the Earth, right? And the moon is about 1/4 of the size of the Earth. However, in the sky, somehow, some way, and just by the distances that work out, the moon can actually block out the sun, called an eclipse. We just go, oh, cool, an eclipse this year. Nowhere else in our solar system is that even remotely possible. It's crazy that the moon, being so small, and the sun being so large, would be the same size to our eye. And so Metaxas goes into all the things we can learn about science when an eclipse happens and all that kind of stuff. But let's keep going on. I found that just crazy. I was just like, are you kidding me? I never put that together before. The moon and the sun are essentially, and for sure when there's an eclipse, they're the exact same size. But the moon plays a crucial role in maintaining life on Earth in several ways. And some of these you might have heard about. Its gravitational influence affects the planet's stability, climate, and even biological rhythms. Here are the key ways that the moon helps sustain life. So number 1 is the stabilizing Earth's tilt and climate. Anybody heard this before? No? Okay, the Earth's axis is tilted at exactly 23.5 degrees, which gives us seasons. Any deviation here would cause many issues with the climates of Earth.
Some say that the North Pole is moving.
Okay, yeah, well, and I think it does this kind of idea, right? But it's the moon that holds that in check. Yeah. Also, you want to say more on that, or?
Just say that the ice is not where it used to be because the North Pole the axis or whatever it is has moved,
Okay,
just people are saying.
okay. All right. So I guess you're saying two things there. Number one, the axis has changed, and also the North Pole, the position of the North Pole has changed. Okay, I guess we'll have to look into that. Yeah, that'd be worth taking a look at that. The premise here, and I've actually heard this one before, kind of like the distance to the sun, that the axis is so important, and if we were off axis, then we would start to spin out of control. But the axis we're on is perfect to keep us in that, perfect orbit, and the moon is the one that kind of holds us in that position. Okay, so, we can take a look at that. So the moon's gravitational pull stabilizes this tilt, preventing extreme shifts. Without the moon, Earth's axial tilt could vary chaotically between 0 and 85 degrees, causing severe climate changes that could make life difficult, even impossible. So of course you know about the moon and the tides, right? The moon's gravity pulls on the Earth's ocean, creating high and low tides, which is incredible to think about. But we've all experienced that. You've been at the beach and all of a sudden the tide's going out or the tide's coming in and we gotta pack up our stuff or else it's gonna be underwater. So tides play a role in marine ecosystems, helping nutrient circulation and supporting biodiversity. And I don't know if your notes say this, but early life may have evolved in some of these intertidal zones, which is, I don't know whether that's according to Hoyle here or not, but third thing is slowing Earth's rotation. I found this very interesting. The moon's gravity is gradually slowing the Earth's rotation. I don't know if that's part of what you were talking about as well. But currently, the Earth's day is 24 hours. You ever think about why that is? And it's the effect of the moon and the gravitational pull on the moon actually slows us down. If not, we would probably be spinning out of control. Again, scientists are deducing this. So the moon being there is causing the exact right speed of the Earth. If we were going too slow, who knows what would happen. If we were going faster, maybe we would all fly off. I don't know. Here we go. Slower rotation makes for a more stable climate and longer, more manageable days, which benefits life. Protecting the Earth from asteroid impacts. So the moon acts as a shield. I don't know if you've ever looked at the surface of the moon. It looks like, dang, it's taken a lot of asteroids, but for the Earth, I'm like, you look around, you're like, I think we look pretty good for being however many, 400 million years old or whatever we are. So the moon acts as a shield, absorbing and deflecting asteroids and space debris that might otherwise hit Earth. While it doesn't block all impacts, it has taken many hits, judging by its complexion, that might have been catastrophic for Earth. Number 5 is influencing biological rhythms. So some animal behaviors, such as reproduction cycles, migration patterns, hunting habits, are influenced by the moon's light and cycle. Have you guys ever heard this stuff before? This is all, sometimes it can get really far out there, but there's no, you ever have that thing if you're in social services and you're like, what is it? Is it a full moon? Right? And you're just like, everybody's just going crazy, or people have headaches or whatever. Corals, for example, time their spawning to the lunar cycle. Okay, so what would happen without the moon? Extreme climate changes due to unstable axial tilt, weaker ocean tides affecting marine life and nutrient cycles, shorter days leading to stronger winds and extreme weather, more asteroid impacts on Earth, possible disruption of biological cycles. When you see the moon, just say, thank you, Lord, for the moon. Good job. I love it. I love looking at it, and I also am thankful that it helps us. Okay, so there's a little conclusion there, but let's just keep going. So here's what we were talking about with Jupiter and Saturn, Earth's order in the universe and galaxy, and its connection to the fine-tuning argument. You guys still okay with this? Because it's kind of getting weedy, and it gets a little bit more weedy because we're going from Earth to the moon, and then we're going to go way out there. The position of Earth in the universe and within our galaxy plays a crucial role supporting life. Many aspects of Earth's location appear fine-tuned to create the precise conditions necessary for complex life to exist. This aligns with the fine-tuning argument, which suggests that conditions are so rare and precise that they may indicate a purposeful design. So Earth's placement in the universe. This is the Goldilocks planet in a Goldilocks universe. The Earth is located in a universe where the laws of physics, gravity, electromagnetism, and nuclear forces are finely balanced. And if physical constants like the gravitational constant, cosmological constant, were slightly different stars, planets, and life itself would not exist. That's a mouthful. There are a lot of words there that we don't say every day. Okay. We'll define that a little further as we go along. The cosmic structure and protection. So the Earth resides in the Virgo supercluster. Again, never heard that before today. It's a vast collection of galaxies, but is not too close to high radiation galactic centers where the supernova and black holes could be harmful. And the universe's large-scale structure allows for stable galaxies to form, with spiral galaxies like the Milky Way being particularly favorable and for habitable planets. Okay, let me just read this and then I'll dial back and just give a little bit more definition here. Earth's location in the Milky Way galaxy. Earth is in a relatively safe region of the Milky Way, 25,000 to 27,000 light years from the galactic center. If Earth were too close to the center, high radiation supernova black hole would disrupt life. If Earth were too far, there wouldn't be enough heavy elements for rocky planets and life-essential molecules. Okay, and let me just read this. Milky Way is a spiral galaxy which provides a relatively stable environment. Unlike elliptical galaxies, which lack heavy elements in planet formation, and irregular galaxies, which have chaotic conditions, spiral galaxies have orderly star formation and supports habitable planets. Earth's location keeps it away from the dense, dangerous spiral arms, which contain more supernova and harmful radiation. Anyone still awake? Okay, so what are we saying here? What are we saying? Anyone? Bueller? Okay, so you know we're on Earth and we're in this solar system of 9 planets, right? And you know that solar system is in a galaxy called? Milky Way. Have you seen pictures of the Milky Way? Okay, so it's a spiral galaxy, means it has all these tentacles that are kind of flaring out. I should have had a picture. And so if you ever have looked this up, sometimes people have those shirts and it says "You are here" and it has the Milky Way galaxy and it has a little, dot with an arrow. And so what they're saying is we're not in the middle. If we were in the middle, everything would just be too dense and fiery and nothing would survive. And we're not on the outside. If we were on the outside, everything would just be chaotic and loose and all that stuff. We are we're tucked in the middle of one of these arms of the Milky Way galaxy. So as it pertains to our solar system, third rock from the sun, right? Protected by Jupiter and Saturn. Our moon is protecting us as well. And also in terms of where our solar system fits into our Milky Way galaxy, it's perfect as well. Okay? Fine-tuning. Fine-tuning. All of this didn't happen by chance. So then when we think about our sun, if you go down, anybody have any questions or comments on that? You guys think about where we are in the galaxy all the time, don't you? It's
when you're camping.
Exactly. And then you sit around the fire and you have all these amazing conversations. Now you can add to the mix. Hopefully you remember one thing from tonight and then you can say, hey, I heard this thing once, Fine-tuning universe. Yeah, bring your hand out to the fire. Remember back when we talked about the solid state universe and the universe was not expanding? They used to believe, before the Hubble telescope, that's how groundbreaking this was, they used to believe that the Milky Galaxy, the Milky Way galaxy was all there was. And now, because of telescopes, there's trillions of galaxies with billions of stars inside of each one of those galaxies.
Haven't they just said recently there's another 6 galaxies that they see?
Yeah, maybe.
Something like
Well, because this new James Webb telescope is out there right now, sending back And it has the ability to kind of, because of the way it takes pictures, to look back into the past, right? Because obviously all of those stars are light, and the light all travels at the speed of light. We won't get into that, that's math.
So how great is our God?
How great is our God, right?
That's a song.
Like, we're literally sitting here, and life could not have happened unless all of this stuff was specifically designed, and we haven't even hit it all yet, and then we got 2 more weeks to come as well. So the sun is a G-type main sequence star, which is neither too massive, which would burn out too quickly, or too small, which would not provide enough energy. The sun has a stable output of radiation and energy, making it variable, unlike many variable stars that experience intense flares and irregular cycles. So God put the exact right star, being the sun, in our solar system. If it was too big, it would have burnt out. If it was too small, we wouldn't be getting the energy from it. That's pretty simple. The sun's chemical composition, also the sun has the right balance of metals and light elements to form planets. Like Earth, it is not part of a binary star system, which could create gravitational instability for planetary orbits. Okay, so that's in there. The Earth's position in the solar system, we kind of already talked about this. The circumstellar habitable zone, the Goldilocks zone, perfect distance from the sun, not too hot, not too cold. We talked about that, allowing for liquid water and essential for life. The Earth were too close, like Venus, would have a greenhouse effect, making it too hot. Too far, like Mars, it would be too cold to support stable liquid water. Okay, so we've already covered that. Jupiter and Saturn, we talk about this as well. I told you we were going to double down on this. Gas giants, especially Jupiter, protective barrier against asteroids and comets. And Jupiter's massive gravity deflects many potential Earth-impacting objects, reducing the frequency of catastrophic collisions. And then the moon's stabilizing, so we're doubling down on that too. We don't have to read that, we've already gone through that. And then number 7, connection to the fine-tuning argument. So the extreme precision of the Earth's position in the universe and the galaxy and the solar system is often used as evidence in the fine-tuning argument for the existence of a designer or intelligent cause. So number 1, the improbability, the conditions for life are so precise that it seems unlikely that they happened it seems unlikely they happened by mere chance. In the video that we watched on fine-tuning, all of those comments that were all about, hey, this just makes sense, that there's somebody who designed all this, were all from atheists. Every one of them. Even, well, you saw Stephen Hawking, right, who said, you know, this couldn't have happened by chance. It's, you know, in Metaxas's book, he says it's a monstrous series of coincidences that land us here. And so, again, we're looking out, we're talking about our planet and all of the galaxy. In the next couple of weeks, we're going to talk about our anatomy and how our bodies work and how, you know, cells were formed and all of that kind of stuff. Again, look up some Frank Tour videos. He'll you know, just blow your mind as well. So here's one that you may remember from your science classes. The 4 forces in the universe. Okay, so they're listed here. I was going to do a pop quiz, see if anybody remember what the 4 forces of the universe is. I wouldn't have got it. But when you think about this, all of a sudden it starts to make even more sense. And again, we're going to go down into atoms here. These forces hold the universe together, and all of these and their current values were immediately present and available at the moment of the Big Bang. The moment the Big Bang occurred and have not changed in 14 billion years. Just wrap your head around that, right? Because they say, oh, there was a Big Bang and all these rocks flew out in space, then the rocks stopped, and then there was water, and then there were these cells in the water, and the cells got together and created a person or fish, and then an ape, and then us. That's the story of evolution, essentially, right? You know, they don't factor in the fact that all of these laws of gravity and everything else were present right at the beginning. Right at the very beginning, when the Big Bang happened, all of these scientific things were present. Things like, A, gravity. Now, we've heard this before. If gravity were any stronger, I mean, that would be terrible because already gravity takes a toll, right? If gravity was any stronger, I mean, we wouldn't be able to, we'd be trying to walk, you know. And if it was any weaker, like on the moon, we'd be like, you know, I'll be there in a second, I just bounce, you know, you're bouncing around, you're trying to figure it out, like with cars. Have you ever played that game? I played that game before where if you drive a car on this planet, it looks like this, and if you drive a car on this planet, so if you get into an accident, you know, on some of them where there's no gravity, the car just flies off into the air, it's just crazy. But gravity is exactly what we need. Like it just works, and there's lots of detail here. That's the one I think most people would get, so I didn't really expand on that too much. Here's one that you probably didn't think about. The electromagnetic force. So Vince, you were talking about the North Pole and the South Pole, and this idea that there's a charge on everything in the universe, right? There's this electromagnetic force. Iron is only created in supergiants, so this is a deal about stars, and so they're talking about iron. Anyways, I probably shouldn't have put this in here. It's this concept. Do you guys know about atoms? Atoms, you remember that? Little tiny things, everything's made up of atoms. And so atoms in and of themselves, there's an electromagnetic thing that happens with regard to atoms, and there's attraction, and of course with magnets, and all of those things. This is something we take for granted. Just trust me when I say that in our world, this is perfect. It's absolutely perfect. And if it was not absolutely bang on precise perfect, all hell would break loose. Okay? That connects with these next two things, weak nuclear force and strong nuclear force. So when you're thinking about weak nuclear force, you're thinking about the force that allows electrons to move from one atom to another, and also to help them stay perfectly calibrated, so they stay, in their atom as well. So the ratio between the strong and the weak nuclear force has to be in the perfect balance. Okay, and then we'll read the next one, and then we'll give a little bit of an analogy for this too. Strong nuclear force, the force keeping protons and neutrons. So if you know of an atom, it's neutron, electron, and proton. The force keeping protons and neutrons together. If they were 2% weaker, they wouldn't stay together. And if they were 2% stronger, everything would be too strongly held together. So again, we're back to the Goldilocks. So if you don't remember anything else, just remember Goldilocks. And it basically applies to everything in this argument. You know, when you think about the chair or this music stand, the atoms that are in here are stable. And they stay exactly where they need to be. That's the strong and the weak nuclear force in action, right? If we take stuff like food and the weak nuclear force, when we eat food and consume food and then we digest food and all that kind of stuff, and I'm out on a bit of a limb here, but it's the idea that some atoms kind of let go when they need to, and some atoms hold tight when they need to. You know, it's where we're all made up of atoms, and we have a beginning point and an ending point, right? Like we stop at the end of our skin. Well, who designed all that? How did that all take place? And it happens all, trees and all of that stuff. So again, four forces that we rarely think about, if ever. They're all perfect for life as it pertains to atoms and all of that stuff. Okay, number 4, and this is the last one. The fine-tuning argument suggests that the fundamental constants and conditions of the universe are so precisely set that they appear to be deliberately calibrated for life. Water plays a crucial role in this argument, as it possesses unique properties essential for life, and it requires very specific conditions to exist in liquid form. The presence and abundant liquid water on Earth is often seen as further evidence of fine-tuning. Okay, you with me on this? So we've gone from the history and all these guys, all these physicists duking it out about solid state universe and all this stuff, out to our galaxies, and now we're literally like, hey, I like water, I drink it all the time, right? Water is particularly fine-tuned. When they send rovers out onto Mars, what are they looking for? Water, why? Because water is a sign of life, right? And we know what water is what? 2 hydrogens, 1 oxygen?
H2O.
H2O. So 2 hydrogens, 1 oxygen. So again, if you wanted the science of that, you go back to the magnetic force. If you don't have a strong enough force, those particles don't come together, you don't have water. And then if they come together too tight, well, all of a sudden you got water, but it's a different consistency. You with me? So this is something we can totally relate to. All the other stuff is scientific gobbledygook, and maybe we get it, maybe we don't. I failed grade 9 science, man, so I don't know why I'm holding the mic. However, here we go. So the fine-tuning of water's properties. This actually just blows me away. Number 1, they consider, or A, I guess it is, the universal solvent. So water dissolves a wide range of substances, making it the perfect medium for biochemical reactions. We know that because we make tea, we make coffee, all this stuff. We're like, yeah, just put in some water. Number 2 is it allows nutrients, oxygen, and waste to be transported efficiently in cells and living organisms. So again, if you want to get rid of a cold or a flu, what do? Drink lots of water. Without this property, complex chemistry needed for life wouldn't function. So water is just awesome. It's something kind of like the moon. We just take it for granted. Oh yeah, there's water. And for sure for us in the Western world, we just turn on the tap. You know, there's people in other countries that are walking miles and miles and miles, and then, you know, going through the sludge and going, I hope I don't die from drinking this today. You know, and so it's something that it's very close to us, but we take it a little bit for granted. Check out some of this science about water and how perfect water is for us. Number B, I guess it is letter B, is expansion upon freezing. Here's one that I don't know if you've thought about. In the book, he talks about this, and I never thought about it before. Water is lighter as a solid than as a liquid.
Wow, I would never have thought that.
Right? Like I'd be hard pressed to think of another element that would float in its own liquid. But if you put ice cubes, or you go to Newfoundland, right? Watch the glaciers float down the icebergs. This is crazy. But when you think about why that's important to our Earth and how perfectly fine-tuned our Earth is based on this, it gives it even more power. Water is one of the only substances that expands when it freezes instead of contracting. This means that ice floats, forming an insulating layer on the top of oceans and lakes, preventing them from freezing solid. And the third one down, if ice sank, bodies of water would freeze from the bottom up, making life in aquatic environments impossible. You ever think about that? Never thought about that. You know, he in the book talks about the fact that if ice started from the bottom, it would make sense, it would start from the bottom and then it would just displace all the water that was on the top. So you'd get flooding and then you wouldn't have any water and it would melt and then you wouldn't have any water in your lake. But then by the same token, all the fish, like what would happen to the fish? What would happen to all the plant life? So this has been going on for however many thousands or hundreds of thousands of years our Earth has been here. Freeze, thaw, freeze, thaw, freeze, thaw. Perfect for exactly what we need. Letter C, high heat and capacity and climate stability. So water can absorb and store large amounts of heat without extreme temperature changes. This helps regulate Earth's climate, making it stable enough for life. If water had a lower heat capacity, Earth's temperature would fluctuate too dramatically. You know, when you think about the ocean, what do they say? The first 10 feet is a certain temperature, and then you go down the next 10 feet and it's another temperature, and then below there it's like so cold you can't even exist. You know, and obviously the heaviness of water as well. But I never thought of it as being kind of a cooling agent for Earth. You know, but I mean, there's so much water in the Earth. Okay, so letter D, high surface tension and capillary action. Water has a high surface tension, allowing it to form droplets and enabling capillary action, which helps transport water and nutrients in plants. So cool. And this is essential for ecosystems and agriculture. Okay, so this is where I think this is the moneymaker here when you think about water. You ever think about the viscosity of water? And if water was less viscose or it was more viscose, there would be some effects. So look at this. The viscosity of water provides much needed erosion. So I never thought about this, but water carries nutrients, minerals, and metals wherever it goes. When you think about that, plants and animals provide, I guess water provides, whatever, this is a bad sentence. Plants and animals provide nutritions. Sorry guys, must have been late in the day on that one. But water provides nutrients, minerals, and metals for animals and plants needed for life. So, you know, you think about this, and our gardens will be coming up soon, and you have to put your water in, but you also want nutrients to go in there, right? And, you know, all plants and animals need that kind of stuff. So we need it, we need water, we need to be, you know, constantly nourished, all that stuff. The water cycle, which is so important to life on Earth, the water molecule is light enough to rise into the atmosphere, but then heavy enough to fall back to Earth by the way of precipitation. You ever think about that, water cycle? Like, incredible. You know, it doesn't happen where it's like, oh, it's gonna rain hydrogen today. Or it's gonna rain, you know, helium today. No, it's just H2O, it's just the combination of the two. And it's light enough to actually find its way up into the atmosphere, and where hydrogen and all those other things will stay up in the atmosphere, when it comes together, oxygen and hydrogen, it will come back down as precipitation and obviously give life to Earth. And then check this out, the viscosity of water allows for our blood, which is made up of 80% water, to be the perfect viscosity to both flow throughout the body as well as coagulate when needed. So I know some of us may be on blood thinners in the room, right? But for years, I mean, your blood, you don't even think about it. Your blood is the perfect viscosity, which is made up of mostly water, and it just goes through your body, giving oxygen to every part of your body. Viscosity of water is perfect for the roots of trees to suck up water to the tops of the trees, and also the ability to cut through mountainous rock. I present to you water.
Is that when, you know, people use saws and they're watered?
Yeah, well, that's a different thing.
Okay.
That's called a wet saw.
But you know what I mean?
Mhm.
Water sprayed out. and they
Yeah,
cut.
well, they do have the ability to cut with water, but I think what you're talking about is something different, where they have an actual saw wheel, and then they put water on it for cutting stone and stuff like
That's
that.
high pressure water.
High pressure water, yeah. So there's both. Yeah. Okay. So let's go down to number 2, connection to the fine-tuning argument.
Oh, we missed a spot.
Oh,
The rare earth.
Oh, the rare earth hypothesis argues that while water is common in the universe, the specific conditions required to maintain stable liquid water for billions of years are extraordinarily rare, further supporting the fine-tuning argument. Thanks, Vince. So again, we have water, but this isn't a new thing to Earth. We've had it the whole time. And when you think about a place like Mars, they're going, we think they had water at one point. There are evidence of lakes and all that kind of stuff, but where did it all go? You know, and so again, we've had it and have it, right? So again, there's tons more stuff on this, but we're just kind of scratching the surface. So fine-tuned laws of physics, water's molecule properties seem designed for life with unique heat capacity, solvent abilities, and expansion properties. Fine-tuned cosmic conditions, the physical constants, gravity, electromagnetic force, must be right for water to behave as it does. Okay. In this next piece, the key aspects of fine-tuning argument drop down to number 3. The 3 possible explanations. So they went over this in the video. And option number one, so here's the thing. We're deducing that all of this exists, right? We're in the right place in our solar system, right place in our galaxy. Earth's the right size, moon's the right size, sun's the right size, all the right distances. That's crazy. Like, how did that all happen? And then this idea about water and just all of these things. It's like, yes, somebody's put all this together, right? All these electromagnetic force and the nuclear force and weak and gravity and all those things. Like, who did this? There's a beginning of the universe. It's moving, it's expanding. It means there was a point in time when it wasn't, and then there was. And we have this book that says, in the beginning, God, said, let there be light, and there was light, and the heavens and all those things. And we're kind of like, wait a second. The more I look at this, it looks more like there was a designer intent on, designing. So the other options here are really the rebuttals against this whole fine-tuning argument. So number one is the necessity argument. The constants of nature must have these values out of physical necessity, but there's no known reason why they must be what they are. The kind of thing is, it's almost like chance in that this type of life was formed by necessity out of what our environment gave us. Right? You with me? So we just kind of formed, like it just was kind of happenstance. If it was in a different place, life would have came in a different way. But by necessity, like this is the whole deal about evolution. Why did we develop an eye? Right? Like that's a great argument for evolution. It's the idea of necessity. Well, we needed to see. Well, how did we know we needed to see? What did we need to see? Like, was it dark? Was it light? Was it whatever? But somehow, some way, over a gajillion years, all of a sudden an eye formed, and now we can see. Oh, now we have magically two of them, and they work together by crossing over and upside down and right side. It's like what? So this whole idea of necessity is kind of like, well, what comes first, the chicken or the egg, right? What comes first, the need to see or the eye? It's like, oh, cool, I got an eye. You got one? No, I don't have one. Oh, well, sucks to be you. Survival of the fittest. I guess I'm going on, and you're not. And so the idea here is that it was just kind of we had what we needed for what needed to happen. And then the second idea is chance, which the universe just happened to have the right conditions by pure luck, although the probability is extremely low. When you factor in all of the stuff that we've talked about tonight, and again, we are literally just scratching the surface on all the things that could be listed out. I think there's one guy I listened to today, he's up to over 800 things. We're just like, man, he's a massive scientist, but he says up to over 800 things. So the other option that we have is that fine-tuning is best explained by an intelligent designer who set the conditions deliberately for life on Earth. A little bit of a different story than what the scientific world would want us to believe, right? So if we go back to 49, where the Big Bang started, we go back to the Scopes trial, and Darwin and evolution, and where we were shamed into thinking that God could create the world and all of the things in the universe in 6 days. It's like, oh, that's some kind of fairy tale. And then 1966, is God dead? In that, this is a little bit of a tip for next week, or next session, is in 1966, what they did was they took 4 amino acids, and they put them in a soup, and then this is the way they believe life started, was there was all these amino acids in the primordial ooze, and there was some kind of electrical lightning storm. It was like, well, where did that come from? Anyways, presume that happened. It hit the water, and then when that happened, things came together, and that was the spark for life. That's really what they believe actually happens. So, in 1966, and Metaxas goes through this in his book, in 1966, when they said, is God dead? It's because they created life. They created life by doing this. They took all the right amino acids, they put it in a big soup, and then they struck it with electricity multiple times. I'm really butchering their amazing experiment. However, they made life out of this thing.
Frankenstein did it.
What's that? Frankenstein, yeah, that's right.
Is that Dolly you're talking about?
What's that?
Dolly?
No, that was the 90s. That was replicating genes or something, right? Yeah, the sheep, yeah. No, but here's the thing about that, and this is what James Tour will tell you, is that from that day, even though they made this big proclamation, oh, God made life, well, we can make life in an aquarium, so how good is God? The thing that he'll say is that from that day till this, they haven't made one step further. And they had to get all those amino acids from somewhere. Like they had to, like, it wasn't like, oh, there's one on Pluto and there's one on Neptune and there's one on Mars, and how are they going to come, right? They were like, oh, we'll take this and take this and we'll take all the building blocks of life and put it in the same spot and then strike it with electricity. And so James Tour's premise is that, we think of the initial cell that began life as this little piece of jello that was just two amino acids that came together randomly. And all of a sudden it's like, oh, those two amino acids came together and they just grabbed another amino acid and then they formed and they just kept growing until they became a person or whatever, a single-celled organism. But again, I'm tipping my hand for next week, but he goes, if you look at one cell, and you look at it through a microscope that, allows you to look at these things, you will notice that in that cell are cities of things that are working together to make that cell live and grow and move forward. And he's like, so you have to explain to me how that all happened first before you can say this cell and this cell got together and made life. You have a lot more work to do. And so the whole, they don't like him because he points the finger at that. It's like, sure, you took 4 amino acids in 1966, put them together and created life. Okay, what have you done since then? Plus, since then, we figured out that it's not this little tiny glob of whatever that is a life cell. Actually, when you look into a cell, it's basically a city with all kinds of roadways and, its organization and all of these kinds of things. And then they discovered DNA and all the way down, right? It's mind-blowing. The point, hopefully the takeaway tonight is that we can feel secure, encouraged, strong in the fact that what we believe, as we believe in a creator God, it's right in line with exactly what the science will tell us, what the science is telling us. It's just, you're just not going to hear it out there.
I don't think they ever considered that there had to be an order
Yeah,
for life to survive. Like, as I read Genesis
yeah,
from the Gospel Tool, God put everything in the exact order it
Yeah.
needed to be for survival
true,
of each thing.
right? Yeah. Do you want to expand on that for non-gospel tool people?
In the beginning, when it talks how God created the heavens and the earth, he starts by creating, on the first day he creates, I can't remember, but he creates what he creates. But if he didn't create, say it was earth first, there would be no room for the water. So without the earth, there's no water to stay on the earth. Without the water, there's no plants. Without the plants, there's no humans and animals, because it all takes that to sustain the life for
Right.
each thing created.
It's powerful,
Mm-hmm.
right? Like, and again, we read that as if, oh, that was written today. That was written
Right.
thousands of years ago.
Right.
And again, some people will debate, oh, was it allegory or is it literal? Did God actually create it in 6 days, or was it 6 units of time, or 6 separations of time, or whatever? But it doesn't matter. Like, to your point, it's like, no, it's light first, and then the firmament next, and the land next, and then we'll separate the water and the land, and then, okay, now we're going to put fish in there, and we're going to have, and all the ecosystems first, and then after all the food is ready, then we'll put man in there. And it's just like, yeah, like somehow they just wrote it down. And this is the order it would have to go in.
Right.
Like thousands of years ago.
So they can't prove that order.
Right. Yeah. It's yeah, it's pretty astounding. Anyone else? You got any other thoughts?